Good morning students. Today we will start product theorem. Yesterday we have studied Cauchy product of the series. Today we will study product theorem. Firstly, you should know what is the statement of product theorem. If summation an and summation bn are two non-negative term series, that means positive and maybe 0, which converge to a and b respectively, then show that their Cauchy product summation cn also converges to a into b. Now because summation an and summation bn are non-negative term series converging, that means their partial sums must also converge to a and b. So let an, bn and sn denote the sequence of partial sums of the series summation an, summation bn and summation cn respectively. That means limit n tends to infinity an is a and limit n tends to infinity bn is b. You already know this concept very well. If any series summation an is convergent, that means the sequence of nth partial sums of this series is convergent. Means limit n tends to infinity of sequence of partial sums is that finite term. Now we write summation cn as c1 plus c2 plus c3 up to cn, and c1 is a1 b1 plus c2 means a1 b2 plus a2 b2 plus a2 b1, and last cn is a1 bn plus a2 bn minus 1 plus a3 bn minus 2 up to an b1. How we are taking this? See in the table. This is not Cauchy product. Means for the multiplication of two series we have two methods. Firstly, I had discussed earlier yesterday, and now I am discussing the second method. See the table. In the previous table we have taken the elements diagonally, but here we are taking according this. See, firstly we have taken a1 b1. Firstly, we have taken this a1 b1. Secondly, a2 b1, a2 b2, a1 b2 and a2 b2. Okay, you have to take this square means rectangle. You can say rectangle. Firstly a1 b1, second rectangle is a2 b1 plus a1 b2 plus a2 b2. Third is a3 b1 plus a3 b2 plus a3 b3 plus a2 b3 plus a1 b3, and similarly more. So nth is an b1 plus an b2 plus an b3 plus an bn, a3 bn, a2 bn and a1 bn. So this is the second method of finding out the multiplication of two series, and here we are taking this concept c1 a1 b1, c2 a1 b2 plus a2 b2 plus a2 b1, and c3 is a1 b3, a2 b3, a3 b3, a3 b2 plus a3 b1. So this is the second method of finding out the multiplication of series. Here we are taking that. Now Sn means c1 plus c2 plus c3 plus cn. That means Sn is the sequence of nth partial sums of the series summation cn, where c1 is a1 b1, and a1 b1 can say capital A1 into b1, and c2 is a1 b2 plus a2 b2 plus a2 b1. Then it can be written as a1 plus a2 into b1 plus b2 minus a1 b1. So a1 plus a2 means sum of two terms of partial sum of two terms of the first series summation an. So a2 means a1 plus a2, and b2 means sum of two terms of the series summation bn, b1 plus b2. So a1 is only first term, means a1, and b1 is first term, matlab sum of first term, that means first term b1. So it is a2 b2 minus a1 b1. Similarly c3 is a1 b3, a2 b3 plus a3 b3 plus a3 b2 plus a3 b1. So it can be written similarly like above, a3 b3 minus a2 b2. So that means continuing this process, cn is an minus 1 bn minus 1. So Sn can be written as c1, which is a1 b1. So that means a1 b1 plus a2 b2 minus a1 b1 plus a3 b3 minus a2 b2 up to so on an minus 1 bn minus 1 minus an minus 2 bn minus 2 plus an bn minus 1 bn minus 1. So cancelling out these terms, first from third, second from fifth, and this from next, Similarly, we will get this a n b n. Okay. Now limit n tends to infinity Sn is limit n tends to infinity a n b n. That means limit n tends to infinity a n multiply with limit n tends to infinity b n. This is a, this is b. So limit n tends to infinity Sn is ab. That means the sequence of nth partial sums of the series summation Cn converging to ab. So sum of summation Cn, that means ab. So it converges to ab. So this was our product theorem. Next concept is Cauchy's theorem. It is also important. Cauchy's theorem. Cauchy's theorem says that if summation an and summation bn are two absolutely convergent series such that summation an is a and summation bn is b, then the Cauchy product series summation cn is also convergent and converges to ab. See, summation an is a and summation bn is b. Cauchy product series summation cn is also convergent. Yani firstly you have to prove summation cn is convergent and then you have to prove it converges to ab. So start, prove. As the series summation an and summation bn are all absolutely convergent, that means summation mod an and summation mod bn are convergent. Absolutely convergent definition says that the absolute values, we have to take the absolute value of each term. That means summation mod an and summation mod bn are convergent. Now let summation an mod converges to a dash and summation bn mod converges to b dash. So because the series convergent, that means the sequence of partial sums of nth terms converges to that limit. So if summation, if an dash, bn dash denote the sequence of partial sums of summation an mod and summation bn mod, that means limit n tends to infinity an dash is a dash, limit n tends to infinity bn dash is b dash. Now the series summation an mod and summation bn mod are series of positive terms and converging to a dash and b dash respectively. Therefore, their Cauchy product converges to a dash b dash. We know by previous result, if the series are absolutely convergent, that means series of positive terms are convergent, then their Cauchy product always converges. It is important result. If the series of positive terms are convergent, then Cauchy product is always convergent and converges to a dash into b dash, the product of their limits. That is summation an mod into summation bn mod is summation dn, where summation dn converges to a dash b dash. Now dn means mod a1 mod bn plus mod a2 mod bn minus 1 mod a3 mod bn minus 2 up to mod an mod b1. This is the multiplication of series Cauchy product. How we have taken this table, from this table, okay? And because dn is the multiplication of these two series which are in mod, so we are taking this, okay? Now we know that absolutely convergent series are convergent. This is very important result. You know every absolutely convergent series is convergent. Therefore summation an and summation bn are both convergent. Okay, now to show summation cn is also convergent. Okay, you have summation dn is convergent, not summation cn. Now firstly show summation cn is convergent and then show this converges to a into b. Now summation cn is convergent, so firstly check it is absolutely convergent. If it is absolutely convergent, then summation cn is convergent. So cn mod is mod a1 bn plus a2 bn minus 1 up to an b1. This is the product, okay? Less than or equal to triangular inequality, apply triangular inequality, less than or equal to a1 mod into bn mod plus a2 mod into bn minus 1 mod up to an mod b1 mod, and it is dn from above, okay? Dn. So Cn mod less than or equal to Dn, and because if big series is convergent, then small series is also convergent by comparison test, okay? So this is absolutely convergent, that means it is convergent. Now to show it converges to AB. So converges, that means the sequence of nth partial sum of this series must be convergent to AB. So let's Sn is the sequence of partial sums of summation Cn, and Sn dash is the sequence of partial sums of summation Dn. So Sn is C1 plus C2 plus C3 plus Cn. C1 is A1 B1, C2 is A1 B2 plus A2 B1, or C3 is A1 B3 plus A2 B2 plus A3 B1, and so on. Cn is A1 Bn plus A2 Bn minus 2 up to An B1. So A1 into means take common A1 from all the terms. So A1 into B1 plus B2 plus Bn plus A2 into B1 plus B2 plus Bn minus 1 up to An B1. That means now take An into Bn. An into Bn means An means n, nth partial sum of the series summation An, and this is nth partial sum of summation Bn. So it will be, you can check, A1 into B1 plus B2 plus Bn plus A2 into B1 plus B2 plus Bn plus An into B1 plus B2 plus Bn, because if this is common, then we have A1 plus A2 plus A3 plus An. That means A1 plus A2 plus A3 plus An into B1 plus B2 plus B3 plus Bn. Okay, you can write this. So this is 3 and this is 4. Now subtract 4 from 3, that means Sn 4, subtract 4 from 3. So that means left side is Sn and left side is An Bn, so Sn minus Bn, and right side this cancels this cancels this, and we get minus A2 Bn. Okay, similarly minus A3 Bn minus 1 plus Bn, and minus An B2 plus B3 plus Bn. Now take mod less than or equal to A2 mod Bn mod plus A3 mod Bn minus 1 plus Bn mod up to so on An mod and mod of B2 plus B3 plus Bn. Means we have applied triangular inequality 2 times on this right hand side. Okay, so that means Sn minus An Bn mod less than or equal to An dash Bn dash mod minus Sn dash mod, because mod, this is mod, and mod means summation An mod having An dash nth partial sum, and summation Bn mod having Bn dash as its nth partial sum. Okay, minus Sn dash. Okay, so we have limit n tends to infinity An dash is A dash, and limit n tends to infinity Bn dash is B dash. So that means limit n tends to infinity Sn dash is A dash B dash. This is also we have, as this is convergent to A dash B dash. So these 3 results we have already in this theorem. Now use these in 5. So Sn minus An Bn mod tends to 0, because this tends to A dash, this tends to B dash, and this tends to A dash B dash. So A dash B dash minus A dash B dash is 0. Okay. Next, that means Sn minus Bn mod, Sn minus AB mod is, take this, consider this, Sn minus AB mod, Sn minus An Bn plus An Bn means subtract and add the term An Bn. Okay, now apply the triangular inequality less than or equal to mod Sn minus An Bn plus mod An Bn minus AB. So that means, because this tends to 0 and this tends to 0, so left side tends to 0 as n tends to infinity. So limit n tends to infinity Sn is AB. So summation Cn converges to AB. Okay, so this was our Cauchy's theorem, and previous one was our product theorem. So these 2 theorems are clear. I hope these are clear in your mind. And previous Cauchy product of the series I had discussed yesterday. You are clear with that. So these 3 concepts you should clear. Okay, thank you.